Okay, you're welcome to today's lectures. Today we'll take a look at chemistry. Today we'll take a look at chemistry. And because your exam is fast approaching, I told you that we'll do more of question reviews. So in the process of reviewing the questions, we can explain one or two things, okay? So that's the pattern our lectures will take from now henceforth until you write your exam. So we saw questions from gas laws. From gas laws. What are the gas laws, you know? Huh? Charles law, huh? Boyce law, huh? Avogadro's law, huh? Granford Abraham, huh? What of Gerisha's law? What of Darcy's law of partial pressure? Have you said that one? Darcy's law of partial pressure. Of partial pressure. What of pressure law? You know of pressure law? Okay, so we'll solve questions. So from there, we pick questions and solve. So from there, we can now, say one or two things about the laws. Okay? Okay, so let's look at these pre 50 questions. Let's go into the jam questions, gas laws. That should be in page kinetic theory of matter and gas law, page 12 of it. So we'll pick questions there and solve. Okay, let's look at this question that has to do with Boyle's law. Let's start from Boyle's law. Let's start from Boyle's law. All together. Okay. So let me look at this question. These markers are not writing well again. I have to change them. Okay, let me. Okay, let's look at this question. I will write it on the board. Okay, look at this question. The question is from JAM 1991, question 5. Can you solve it? The question says 30 cm cube of oxygen at 10 atmosphere pressure is placed in a 20 cm cube container. Calculate the new pressure if temperature is kept constant. First of all, to solve this question, you should first understand the question. Then know the law that you should use and why you should use that law. These are things you must find out. First is to understand the question. Second is to know the law to use and why you should use it. So what law do you think we can use it? Why do you say so?
Because the temperature is constant.
Okay. Okay. Yes, very important. Temperature is constant. Now, what happens to pressure? Pressure and volume.
Directly proportional.
No. Inverse proportional. Good. Volume is inversely proportional to the pressure. So this is use Boyle's law in solving this question. So can you solve it now? What did Boyle's law say?
The volume of the inverse of gas
Okay.
is inversely proportional to the pressure
Okay.
provided by the
Temperature is what? Constant. Okay. This is Boyle's law. Remember that if you want to remove this sign, you put constant, hope you know. So this now what? K over P, right? That means that K is equal to what? PV, right? Remember that this is constant. This temperature, there may be other factors that should keep constant. Which temperature is one of them? All of them are inside this constant K. Both temperature and any other factor. But our interest is in temperature. So temperature is kept what? Constant. So if temperature is kept constant, that means constant means that it is same thing from one state to another state. From initial to final, the same thing, it doesn't change. That means that even if you like have K1, have K20, K1 is equal to K2, K2 is equal to K3, they are equal. So that means K1 is equal to what? K2. Do you understand this? It's constant. But you know that K is PV. So if K1 is equal to K2, that means P1, V1 is equal to what? Are you following? P2, V2. This is where Boyle's law came from. This is the Boyle's law. Is it clear? So we can actually use this to solve this question. We know the first pressure. We know this first volume. Second pressure. Second pressure, we don't know it. That's what we're looking for, right? But the second volume, we know it, right? Which is what? 2 cm. So we substitute and get our answer. We are looking for what? P2. So make P2 the subject of the formula here. Make P2 the subject of the formula here. If you make P2 the subject of the formula, that means you're dividing both sides by what? V2. Right? So that means P2 is equal to what? P1 V1 over what? V2. So we can now solve it here now, right? So P2 is now equal to what? We know from the question. P1 is what? P1. 10 atmosphere, good. Times V1 is what? 30 centimeter cube. Over V2 is what? 20 centimeter cube. Can you see the board? Okay. 20 centimeter cube. So we can now cancel that, right? CM cube do what? Cancel CM cube, right? 0 will do what? Cancel 0, right? 10 atmosphere times 3 is that. In fact, 2 will cancel 10 here. We have what? 5. 5 atmosphere times 3 is what? 15.0 atmosphere. So the answer is what? 15.0 atmosphere. Is it in the option?
Yes.
Option B. Any question? Please, if you are confused, ask question. I will explain. It's clear. All right, fast. So we can look for another question to solve. Are you done?
Yes.
Yeah? Okay. Let's look at another question. Let's look at this question. It says a given quantity of gas occupies a volume of 228 cm cube at a pressure of 750 millimeter mercury. What will be its volume at atmospheric pressure? Option A 200 cm cube, B 225 cm cube, C 230 cm cube, D 235 cm cube. JAMB 1991 question 6. What do you think? What law should we use here? Hmm? Why? White House law. What is atmospheric pressure in millimeter mercury? You don't know. So continue. You will say something.
You don't have P2.
You say what?
You don't have
P2.
yeah,
What are you looking for?
we are looking for
Huh?
V2.
V2.
Yeah.
P2 is atmospheric pressure. That's why I said about what is value of atmospheric pressure in millimeter mercury. Huh?
Okay, that is all.
It's Boyle's law now. What is atmospheric pressure? Okay, what is standard pressure? Atmospheric pressure is what? Okay, so pressure. So that one is temperature now. 273 Kelvin is temperature. So let's solve this. V1. V1 is equal to what? V2 what? V2. We are looking for what? V2, right? So V2 is now equal to what? V1 what? V1 over what? Over what? V2. We have P1 as what? 750 millimeter. P1 is what? So it's equal to what? 750 millimeter mercury. V1 is what? 228 centimeter cube. P2 is what? 760.
What is the value of this thing in atmosphere?
Value of what?
760 atmospheric pressure.
But A value in atmosphere. You don't have to have to convert it. Huh? How many atmosphere? It's not 1 point. Only 1 time, so it's what? It's 1 atmosphere. It's 1 atmosphere. But in Newton per meter square, it's 1.01 times 10^5 Newton per meter square. But it's 1 atmosphere. So, but it's 760 what? Millimeter mercury. Is it clear? Is it clear? Good. Pressure can be in millimeter mercury, can be in atmosphere, can be in Newton per meter square. In Newton per meter square, atmospheric pressure is this 1.01 times 5 times 10 to the power 5. But here, in millimeter mercury is 760 millimeter mercury, but in atmosphere, it's 1 atmosphere. Is it clear? Good. So, this now, let's divide. Let's divide. This will cancel this. This will do what? Cancel this. Can 76 divide 228? Can 76 divide 228? Is it possible? So 6 times, So 6 times 3 is what? Is what? Do it now. 76 times 3. 3 times 6, 18. 3 times 7. 3 times 7 is 24. 21 plus 1. So you can divide it. If so, 6 divides 2 to 8 is what? 3. 3 times 75 is what? 3 times 75. Clean this and put 5 here. Clean this one. 3 times 5 is what? 15. 3 times 7 is what? 21 plus 1 is what? 22. So 3 times 75 is 225 cm cube. Is the answer there? Option what? So the answer is option what? B. Is it clear? Is it confusing? Good. I don't. Okay. Let's look at this question. The question says the volume of a given gas is V cm cube at P millimeter mercury. What is the new volume of the gas if the pressure is reduced to half at constant temperature? A V over 2 cm cube, B V cm cube, C 4 V cm cube, D 2 V cm cube. All right. What law do you think we should apply here? Boyle's law. Temperature is constant, right? Volume and the pressure vary, right? Solution. This question is simple, just the same thing we will be doing, but they just remove numbers and use figure and use letters. So it's just the same step you take, but there's no number here. Now, as usual, we go to the equation, right? P1 V1 is equal to what? B2 V2, right? Good. From this thing now, what do you think you are looking for? P1 is what from the question? P1 is what? Good. P millimeter mercury. V1 is what? Good. V cm cube. P2 is what? Half of what? So P over 2 now, right? P over 2 is what? You don't have. P over 2 now. If I divide by 2 now, is what is the result we have of P, right? So it's P over 2. So P over 2 watts, millimeter watt, mercury. Then V2 is what? V2 is V2, right? We don't know. So let's make V2 the subject of the formula. So V2 is now equal to what? P1 V1 over what? Over what? V2. Is it clear? So let's substitute. V2 is what? P1 is what? Millimeter, right? V1 is what? VCM cube. All over. P2 is what? P over 2 millimeter mercury. So let's cancel. This will cancel this. If you have something like this, if you have P over 2, hope you know that instead of saying P divided by what? Hope you know. Are you aware? And for the law of fractions, if you want to work on this must change to what? Multiplication. And if you change, this one will do what? Come on. So we have that P times 2 over what? P. So P will cancel what? P, right? So that means these two, P will do what? Cancel P. These two will do what? Come on. Two of us. 2 times V cm cube is what? 2 V cm cube. That's the answer. Is it clear? Are you sure? So the answer is option what? Option D. solve this question. The question says the ratio of the initial to the final pressure of a given mass of a gas is 1:1.5. Calculate the final volume of the gas if the initial volume was 300 cm cube at the same temperature. A. 450 cm cube. B. 200 cm cube. C. 120 cm cube. D. 750 cm cube. Which law? Boy's law. Thank you. Now, ratio has entered. If you don't know how to handle ratios, you know we need to solve this question. Now, let's go to the formula first. Remember that V1 is equal to what? V2. Okay? Good. If they say ratio of A to B is equal to 1:2. Do you know what it means? It means that A over B is equal to what? 1/2. Is it clear? Is it clear? Good. So let's put this thing in this form. Here we have the same ratio of what? Initial. So let's put it in this form where we can get something like where we can place P1 and P2 in this form. P1 over what? P2. Okay? Let's see. Let's try to achieve that. Alright, so to achieve that, remember our target is to get P1 over what? P2. Remember, not P2 over P1, but P1 over what? P2. So to achieve that, our target is P1 over P2. So let's divide both sides by P2 so that we can move P2 here. You understand? Huh? This is simple mathematics now. We want to get P1 over P2. If you want to move P2 to be under here, what are you going to do? You divide both sides by P2. If you divide here by P2, divide both sides by what? P2, okay? Here by what? P2, right? P2 do what? Cancel P2. Is it clear? So we'll be left with what? P1 V1 over P2 is equal to what? V2. Are you following? But we are not done. Here is P2. What we want is P1 over P2 separately. Right? For us to achieve that, we must move this V1 away from here. And if we want to move this V1 away from here, we divide both sides by what? V1. So here is what? V1 over what? V1. V1 will do what? Cancel V1. Hope you know why to cancel it. So we will not be left with what? P1 over what? Is equal to what? We have gotten what I'm looking for. If you like, if you apply it, you will get P1 V1 is equal to P2 V2. Are you aware? If you apply P1 times V1 is equal to P2 times V2. Is it clear? What we need, we just rearrange this to get it in this form, so we can solve this question properly. So if that is the case now, we can now solve the question. Remember what we said, that if this ratio of A to B is something as saying is equal to 1:2. Something as saying 1 over A over B is equal to what? 1/2. True of us? So if that's the case now, we replace if that's the case now, we anywhere we see P1 we put what? 1. Anywhere we see P2 we put what? 1.5. Is it clear? So that means 1 over what is equal to what? V2 is what? 300 watts? No. V2 is what? Unknown now. V1 is what? 300 centimeter cube. I'll clean this question. You covered it, right? Good. 300 centimeter cube. So we cross multiply to find V2, right? So V2 is now equal to this times this divided by what? 1.5, right? 1 times what? 300 cm cube divided by what? 1.5. To avoid punching calculator, hope you know that 1.5 is something as saying 3 over 2. Hope you know. So this is something as saying 1 times 300 cm cube over what? 3 over 2. Is it clear? Remember what we did last time? So this is something as saying 1 times 300 cm cube over 1 times 2 over what? 3 of us. So 3 will do what? Divide 300, we have what? 100. So 100 cm cube times 2 is what? 200 cm cube. So the answer is what? 200 cm cube. So the final volume is what? 12 cm. So the answer is option what? Option B. The answer is option B. Any question here? Are you sure? It's clear? Okay. Okay. This question. The question says 28.8 cm cube of nitrogen at 15 degrees Celsius is cooled to 0 degrees Celsius at constant pressure. The new volume of nitrogen is 17.4 cm cube. B. 14.7 cm cube. C. 27.3 cm cube. D. 31.7 cm cube. JAM 1981 question 30. Which law is here? Huh? What is the Charles law? The pressure is constant. Volume and the temperature vary, right? Okay, so let's solve the question. State Charles law. Volume, to what? Pressure is what? Is constant. Okay? So, what it means is that pressure and any other factor that can affect it is constant, is placed under K. But volume and temperature vary. Now, again, if you want to remove this sign, and put equal sign, you introduce constant, right? So V is equal to what? KT, right? Which means that K is equal to what? V over what? T. Is it clear? Which means that K is equal to what? V over T. Remember what I told you about K being the same thing, whether it's K1 is equal to what? K2. In that case now, if K1 is equal to K2, that means V1 over what? T1 is equal to what? V2 over what? T2. This is Charles law, equation for Charles law. So you use this to solve this question. Is it clear? Now from the option, from the question, from the values given to us, V1 is what? 28 point what? cm cube. V2 is equal to what? Unknown. We are looking for it. Good. Then T1 is what? Do it like that. We change it to what? By doing what? Price no added. You add what? What is that? So if you add 273 to 15 is what? 273 plus 15 is what? Is what? No. Okay. I have 28 what? Good. So this is what? 288 what? Kelvin. T2 is what? Plus what? It becomes what? 273 Kelvin. So we are good to go. So we substitute. First of all, we make V2 the subject of the formula. So V2 is what? We cross multiply, right? Is V1 T what? 2 over what? T1. Right? Good. So let's now solve. V1 is what? 28.8 Kelvin. T2 is what? 273 Kelvin. See it now. Over T1 is what? So this is CMQ, not Kelvin. Sorry. This is CMQ. T1 is what? 288 Kelvin. So Kelvin will do what? Cancel Kelvin. If 28.8 divided to 88, here we 1, here we what? 10. Are you aware? Are you aware? Yes. So 10 divided to 273 is what? 27.3 cm cube. You agree with me? 10 divided to 273. You agree with me? Are you sure? Are you sure? So the answer is what? 27.3 cm cube. What's the option? Option C. Good. Option C. Let's look at this question. The question says, which of the gas laws does the graph below illustrate? Which of the gas laws does the graph below illustrate? If you want to take questions, see the graph. A says Boyle's law, B Charles, C Graham, D Gay-Lussac. JAMB 1988 question 6. What's the answer? What do you say Charles law? Explain the graph. What do you say Charles law? Uh-huh. It's increasing, huh? Good. Look at it. It's faster because for the diagram, even though they didn't mention pressure, but what we can see from the graph, when this is 5, when this at 5, volume 5, temperature non 100. When volume increase to 10, temperature increase to 200. At 300, temperature 300, the volume increase to what? 15. At temperature 400, the volume increase to what? 2. So as the temperature is increasing, the volume is what? Increasing. Is it clear now? So the answer is what? Charles law. Okay, this question says a given mass of gas occupies 2 dm cube at 300 Kelvin. At what temperature will its volume be doubled, keeping the pressure constant? A. 400 Kelvin, B. 480 Kelvin, C. 550 Kelvin, D. 600 Kelvin. JAMB 1992 question 5. Which of the gas laws should we use here? Huh? Gas law. Good. Pressure is constant. The volume and temperature vary. So solution. We have already established Charles law as what? V1 over what is equal to V2 over what? T2. For this question, V1 is what? Huh? 2 watts, 2 dm cube, not centimeter, dm cube. T1 is what? 300 watts Kelvin. V2 is what? V2 is what? V2 is what? How? You spell that here. How is it unknown? He said, at what temperature will its volume be doubled? So how is it unknown? Double of the initial volume is what? Which is now what? 4 dm cube. So V2 is what? 4 dm cube. Good. T2 is what? That's what you're looking for. So we make T2 the subject of the formula here. If you cross multiply, T2 becomes what? V2 T1 over what? V1, right? V2 is what? 4 dm cube, right? So 4 dm cube times T1 is what? Is what? T1 is what? Can you sit up? Sit well, please. Sit well. T1 is what? 300 Kelvin. Good. All over V1 is what? 2 dm cube. Dm cube will do what? Cancel dm cube. 2 will divide 4 to give you what? 2. 2 times 300 Kelvin is what? 600 Kelvin. So the answer is what? D. Is it clear?